How were we with these ones? Were we okay with that, or do you need me to do them? You want me to try that with you? Yeah, because the key was just a snapshot, right? You didn't explain on how I got that. I want to go back and just make sure, or at least before I start here, I want you to think of these expressions. Essentially, at some point, this is going to be a number, and this could also be a number. We're just like writing it in terms of an expression with a variable. Okay, so you need to make sure, don't let that throw you off, okay? And the first thing I think that can be confusing is restrictions. Let's do that first. If you haven't done this, if you have, then maybe just pay attention before I move on, because after this, we're going to do equations, okay? Where it's going to be something, this whole expression is going to be equal to something else, and we're going to actually solve for n, okay? That's our ultimate goal. So what are the restrictions? At the top and at the bottom, there are two there, but we're only going to pick one ultimately. So here's how I'm going to rephrase that. We don't want, I'm going to completely, hold on. Let me redo this because I'm going to block my space here. I'm going to rewrite that here. This is just for you. Hopefully this helps you. We don't want a negative inside the bracket. We don't want a negative inside the bracket. Okay? That's what a restriction is doing. And now it's all blurry. Come on. Focus. There we go. That's ultimately what you're trying to do with a restriction. So you go to the top, and what I always tell my students is just make sure this thing is not a negative. For you to be able to achieve that, you need to say that n has to be 2 or greater. Okay? Then you go to the bottom here. N has to be greater than or equal to. If you think about it, what makes this exactly 0 right now? It would be -1, correct? So you want that to be greater than or equal to -1. You can't go as low as -1, but it better be greater than that, right? Or else you'll have a negative. And you'll soon realize this one is irrelevant to us because this one here already takes care of that. We'll never even get as low as -1. So this is my ultimate restriction for this whole expression. If I meet that, I'm good, okay? Because remember, you can't take the factorial of a negative. That's our goal here. You want to exclude, because later on, I'll tell you this, you're going to figure out that n can be more than one value, and we want to just make sure we can exclude the ones that don't meet the criteria. They don't meet this criteria. Okay, so here we go. Out of these two, which one is the greater number? Like if you were to look at it, and remember, n once you find it is the same. Let's say it's 10, be 10 here, this would be 8, this would be 11. So this is the bigger expression here. So that's the one I'm going to expand. I'm going to keep the top as is, and then the bottom, I kind of write it out. n plus 1. So you take whatever the bracket says, whatever that says, that's what you start with, and then it goes smaller than that. So one smaller than this would just be n. Sure, you can put that in brackets if you want. One smaller than that would be n minus 1. And then one smaller than that would be n minus 2. And that's where I stop. Why? Because I notice, right, that there's an n minus 2 up here. So then you cancel that out. That. And what a lot of students might, what I see in the past is they just write this down. This is my answer, Mr. Dirksen, this one right here. It's like, no, you have something left over. It's 1 at the top. Okay, and then you're left with n plus 1 times n minus 1, like that. So now all you want to do is FOIL that out, right? Distribute that all. Maybe it's easier to think of it this way. I'm going to go n plus 1 times n minus 1. I'm going to write these two next to each other and just have the n tagging along for now. Okay. And so here you just distribute. You go n times n is n squared. N times negative 1 is negative n. Right? And this is plus n. And this is minus 1. And that's multiplied by n. Let's clean it up a little bit. These actually cancel out. Right? It's a difference of squares. So n squared minus 1 times n. And this multiplies that. That'd be n cubed. N minus times negative 1 is negative n, like that. We're good? Is that? Oops, you can't see it. Okay, so don't right now. Don't just follow. You know, you've done these in the past, right? Distribute out. Just do it that way, and you'll be fine. Okay. That's not it. I'm just checking. Was this on the answer key? Is this what we got on the answer key? Are you not sure? Cheska, you're checking for me, right? Is that what it is? Okay. Okay. How many of you did this one? Can you raise your hand if you did this one actually? Okay, not many. So try it now again. Now that I've done another example, try this one. I'll give you, maximum 5 minutes. Give that a try before I go on to the equations, okay? So do what I just did. State the ultimate restriction. I would isolate the top and the bottom for now. Makes it a little easier. Pick the largest one and then simplify it as much as possible. Okay. I'm gonna pause this here. You trying, because if you don't, I don't know where you're at, right? And I can help you out. Don't be shy to ask for help. I think the only thing here, there's the restrictions. You have n, so you don't have to write down top and bottom anymore, right? I just do that for you. This would have to be greater than or equal to -3, and the bottom is greater than or equal to -1, right? So this is the one. This is the one you would want to pick. This one is higher than this one, right? It's closer to 0, right? Above that one. So if you meet that one, you're good to go. So this would be n plus 3 times n plus 2. Because remember, it's getting down by 1 every time. The next one would be n plus 1. I stop there because I have an n plus 1 factorial at the bottom. Cancel that out like that. FOIL it, right? So that'd be n times n is n squared plus 2n plus 3n plus 6. And so it's n squared plus 5n plus 6, and then we're done. Okay? So there you have it. You're thinking, I need more examples. You will get more, okay? Because we're gonna do equations next. So let's do that. Come with me. I'm gonna skip 12 for now. We've done that kind of stuff, but I want to get into the equations. So go to page 14. Highlighters are probably very good to have. Also, your graphing calculator. Okay, this is basically where we're working towards when it comes to factorial expressions. Now we're dealing with equations. Means you have to figure out what the possible value or values will solve the equation. You will recognize this when you see a factorial expression equals an expression. This could just be a number as well, by the way, but that's how you know it's an equation, right? And these are your steps. Some of you like steps, so there they are for you if you'd like to follow them. We'll state the restrictions just like before. We pick the largest. Simplify the factorial as much as possible. That's what we've been doing. Okay, expand whatever is left using a distributive property or FOIL. We were doing that as well. And here's where things change. This is new. Bring everything over to one side. This is important here. You have to, at some point, set the other side equal to 0. That's new. And here are your options. If you end up with an n squared in your final expression, guys, you will have two answers. If there's only an n left, there's just one answer. And then verify your answers. You plug into the original to check if left-hand side is equal to right-hand side. If so, your solution is actually good. Here's what I want to say about quadratic answer, a quadratic situation. Okay, so I'm just going to go, no, don't do this because I want to use it for something more important. I might add this little bubble that I wanted to add later, but if you remember factoring from grade 10 Intro to Applied and Pre-Cal, you can do that. Most of us probably forgot how to do factoring. So this is your next option here. Use the quadratic formula. Do you remember the quadratic formula? Vaguely, that's to find the x-intercepts. Or third option, this is the one that most of you are probably going to use, is use the calculator, graph, and then find x-intercepts. I'm going to review the quadratic formula here. Quadratic formula, this is how you do it. If you think of ax squared plus bx plus c, like if you think of that, the general form of the quadratic, we go x is equal to negative b. I will put everything in brackets, okay? Plus or minus b squared minus 4 times a times c, like that. And this whole expression is divided by, anybody remember? Why would I remember that, Mr. Dirksen? Why? 2a divided by 2a. This is your quadratic formula. This should be on your study sheet if you want to use it. Okay. So this is, I'm going to make an arrow going from here. That's your quadratic formula. Revisit it. And then the last step is use your calculator, right? Enter. So basically what we're going to do is we let y3 equal to 0. And then we go second, trace, intersect. Okay? That's how we do use the calculator to do that. Maybe I'll just say, right, if you use a calculator, which is going to be for most of you, like the graphing calculator, that's how you would do it. So what is new, Mr. Dirksen? It's basically everything from here down to here. And it looks busy, but we're only going to have one of these two scenarios present, right? We're either going to have an n squared somehow or just an n. It depends, okay? So here we go. Let's do an example together. Restrictions. What about what's up with the top? N has to be greater than or equal to 0. If it's just n, n has to be greater than or equal to 0. Because 0 factorial is 1. You can be bigger than that, but you cannot be less than that. At the bottom, n has to be greater than or equal to 2 would make this 0, right? So 2 is the bottom restriction. The overall restriction, therefore, The only one that we're going to care about is that one. Okay, so there we go. We're good to go. I'm trying to come up with an example that will help you with this. Let me just ponder on that tomorrow. I'll have a better illustration for you. So let's do this one. So we pick the one that's the biggest. Which one is the biggest expression here of the two? I would argue n. N is bigger than n minus 2, right? So we're gonna expand that. So n, the next part would be n minus 1, and then the next would be n minus 2, and this continues all the way until you get to just 1, right? But we're gonna stop there because I see that there's an n minus 2 factorial. Let's say you missed the boat. You're like, I'm just gonna expand the bottom. That'd be n minus 2, n minus 3. You would soon realize, wait a minute, I'm not going to be able to cancel this one out, right? If you do it right. Don't forget the 90. Okay, it's following you. This is where this is difference in equation. Let's cancel this out. And you're left with n times n minus 1 is equal to 90. It's pretty neat, isn't it? It's just all that busyness is down to just this. Let's FOIL this out. So n times n is n squared. N times -1 is just negative n. So this is really what it comes down to, and that's equal to 90. Okay. Then you bring everything over to one side. I'm going to bring everything over to the left side. So this is n squared minus n. And the 90, when it comes over the equal sign, turns negative. If you've had me before, I tell my students about that all the time. When you bring stuff over, the sign changes. Okay, here we go. Find intercepts. Hold on, x-intercepts in particular, right? Find x-intercepts. We put y1. Y1, we're going to enter n squared. Oh, sorry. Yeah, we're just going to go with it. It's technically, our calculator doesn't have n, it just has x, but that's okay. We're just going to go with it. So y1, and our first y equals in our calculator, we're going to enter this, and y2 is equal to 0. Then we're going to go second, trace, intersect, which is the fifth option. So here's where you grab your calculator. And if you're new to this, I might have to spend some time with you to figure this out. So basically you want to press y equals. Whatever is in your y equals right now, you're going to clear everything. So you hit the clear button and just make sure everything is gone. Okay. Also, make sure the plots are turned off. So how do you turn them off? Just go right to them, hit enter, and when you move away from it, it should not be highlighted. Okay. So let's enter this here. The button for x, variable x, is right here. It's the x, t, theta, n button. So we're going to press that. Then we're going to square it. Then we're going to go minus n, which is our x button again, minus 90. Enter. And then you let your y2, you actually have to enter 0 into it, like that. Okay, so that's what it should look like. Hit graph. Hopefully it'll show up. If it doesn't show up, I'll show you some tricks, okay? Hit graph. You see one of the legs, because we know this is going to be a parabola. Which way is it pointing, by the way? Let's do some review here. If A is positive, right, if this is positive, we know it's going to go like this. A is positive. It's going to be pointing up. So potentially, like, we know that it's crossing the x-axis twice. This is the right arm. We're going to find the other one. So that's when I press, you can do window, but I'm going to press zoom. And the first thing I would like you to try is zoom standard. You remember this one? It changes everything to -10, +10 in your x-axis, -10, +10 in your y-axis. So hit enter. It doesn't do a very good job, does it? But I can see some of it. I can see this leg here. I can see that leg there. So I think from here, I'm just going to go window, press the window button. I'm going to go X min a little bit further to the left. So I'm going to go negative. You got to press the negative button, not the minus. Okay. And X max, I'm going to expand that a little bit to the right. So I'm going to go 15. Y min, I have to go a little lower on the Y min. So I'm going to go -30 here and leave everything else. So let's hit graph one more time. Oh, I'm pretty good with my X min. X min is this side, X max is here. So I need to decrease my Y min a little bit more. So I'm going to go window, go straight to Y min. I'm going to go -100. I just want to make sure I can see it. Hit graph, and there it is. So again, if you have calculator issues, I can help you later with that. Let's go find the x-intercepts. So we're going to go second trace, right? This gives you a bunch of options here. We're going to select the fifth one here, intersect. You're finding the intersection. So when you hit enter, it's asking you, hey, on the first curve, whereabouts is that x-intercept? So what I tell my students is you go side arrow as close as possible to it. And if you only have two curves, you just hit enter 3 times now. Enter, enter, and enter one more time. And what do you get? You get -9. Okay. So, but basically, when you go to your paper and you say that n can either be -9, that's my first option. But we also know that there's another value for n, which is out here. It's this one out here. So we're going to do this all over again. Second, trace 5 for intersect. Now you got to go all the way over to the next one. That's technically that's close enough. It will just go to the one that's closest to it. Hit enter 3 times. And you get 10. Positive, right? There we go. Now you got to analyze both of these. We need our answer to be greater than or equal to 2, right? Look where my left finger is right here. We've determined that. So this one is out. This one is not acceptable. And the fancy word for it is extraneous. We do not consider that. This one we are going to keep. Right? So this is the one we're going to consider. So we're going to check. We're going to plug this into our original, our very original entry here. Okay, write this down. Equal to 90. Let's plug in the 10, right? So it'll be 10 factorial over 8 factorial, right? Because it's 10 minus 2. And that's supposed to be equal to 90. You can use your calculator here, or I'm just going to do this. The top is bigger. So I'm going to go 10 times 9 times 8 factorial. And at the bottom I have 8 factorial. That's supposed to be equal to 90. You cancel this out. And 10 times 9, you guessed it, that's 90. So left-hand side is equal to right-hand side. So we're good to go. So n equals 10 is our ultimate answer here. It's what satisfies the equation. If you like to use the quadratic formula, I would like to show you how to do the quadratic formula, if you don't mind. At least it saves you from having to graph it. So some students prefer that. So I would also encourage you to write it down just in case. So what I'm going to do here is I'm going to box this whole thing in here and say calculator. Okay. Can I give you another tip for calculator? It's also going to be helpful later on. You can, if you type zoom, technically you can try any of these zooms, guys. You can try it. It doesn't hurt. I'm going to say there's one that says zoom fit. There you go. If you have to go way down past zoom stat, there's zoom fit there, or zoom 0. Sometimes that does a beautiful job, not always. So I'm going to hit that. So that's what you would have seen immediately if you press zoom fit. Okay. I like my students to understand how the window works, but zoom fit, if you know how the window works, zoom fit will often work for you. Okay. It'll just try to fit and try to show you the important points, but not always. Okay. All right. Here's the quadratic formula. So I'm going to box this off here. Quadratic formula. This is already, I have to note that A is equal to what? A is equal to 1. B is equal to what? My finger is right there. It's -1, right? -1. And C is equal to -90. C is equal to -90. And then use your formula. So it's negative B, whatever B is, plus or minus square root of B squared minus 4 times A. This is where you have to be so careful with your signs. Okay. Let me zoom into, can you see that? I hope you can see that. Over 2 times A, and A happens to be 1. I hope I can make this work here, guys. What's negative times a negative? That's just +1, right? Plus or minus square root. And I just tell my students to not mess up here. Just type it into your calculator because you've got them. Why not? Right? You get to use it for the entire exam. You type it in exactly the way you see it. Bracket, -1, close bracket, square it. Minus 4 times 1 times -90. You got to make sure you use the negative, not the minus. That's where this calculator is a little weird. Okay. The negative is down here, guys. Right down here, that's a negative. So the in between is a minus. This is a takeaway. That's why I have it a little longer. So it's, yeah, it's weird. So if we hit enter, you get 361 in here. And then you split off into, oh, sorry, divided by, don't forget about divided by 2. So you split off. Technically it's n, right? Sorry guys, I misled you here. It's supposed to, we're figuring out n. So n, there's one option and another option for n. So I go 1 plus square root, so it's second x2 of 361. Hit enter, then you divide it by 2. So that's 10. That's your one option there. And watch what I do. I just copy paste this expression here. I go 1 minus 361, hit enter, divided by 2, that's -9. But this one, we don't, oh, -9. I kind of want you to see that it's -9, right? But that one is not acceptable, right? So we just pick this one as our solution. So both ways get you there, okay? You don't want to factor. If you want to factor, that's fine with me. Just show me your work and you're good to go. All right. I'm going to stop there. I'm basically just going to ask you to try pages 15 to 16. This is something that with practice you can become really good at. So I'm not going to spend a whole lot of time necessarily reteaching this. I will, probably do one more tomorrow to just ensure that you understand all the pieces that need to happen. But just make sure you know how to do it and you actually give it a try. That's the only way to learn this one.